So what this means is any volatiles will basically be boiled away. If you have a molten surface, anything like water is going to get boiled away.
Young Earth was a dry planet, devoid of all the precious volatiles needed for life. These materials must have been delivered to Earth after its formation. We think volatiles arrived in the early days of the solar system, when the giant planets, including Jupiter, moved around and stirred up the contents of the solar system.
As Jupiter moves, its gravity is pulling on all the objects in there, basically speeding them up. There's a little bit of chaos there in the first place, but now Jupiter is basically supercharging it.
Jupiter's path sends countless asteroids and comets on a collision course with the Earth.
It would have been utterly chaotic. This is a rain of large objects onto all of the inner planets. But these objects that came screaming into Earth were gigantic.
4 billion years ago, a storm of giant asteroids and comets hits the Earth. Some are tens of miles wide. They bring the volatiles that help fill the Earth's oceans and build its atmosphere. But cosmic deliveries can both give and take.
The importance of impacts for atmosphere could go either way. You could have a really big, really powerful impact that blows away the atmosphere of a small fledgling planet. Or you could have a bunch of small impacts of water-rich asteroids that are simply contributing water and volatiles and new chemicals to the surface that might help the atmosphere that's already there.
When you think about an object coming to Earth, is it going to land on Earth? And if it does land, is it going to be an erosive event where material is lost from the Earth, or is it going to be an accretion event where the Earth gains material? Well, the devil's in the details.
Details like the size of the impactor. One study suggests that asteroids between 60 feet and 3,300 feet wide add more to the atmosphere than they take away. And speed at the point of impact also matters.
Asteroids are orbiting the sun, and when they fall towards the sun, they are gaining speed, they're gaining velocity.
Imagine dropping a coin into one of those spiral wells. As the coin gets closer and closer to the middle, it spins up faster and faster.
The closer an asteroid gets to the sun, the stronger the sun's gravitational pull, and the faster the asteroid travels.
So proximity to your star is a vital factor in how intense any impacts will be.
It's possible that the Earth is the right distance from its host star, so that when an impact happens, the energy isn't insanely high, it's just the right amount, that it's the right speed to make everything work.
Supernovas seed the solar system with the elements to build the planets. Asteroids and comets deliver volatile chemicals to the surface of the Earth. Together, they create a habitable environment.
So we need those impacts to happen to have life on Earth.
Disasters created a planet primed for life. But it appears that even more mayhem and chaos are needed to trigger life itself. An asteroid tears through the solar system, hurtling through space at 40,000 miles an hour. Its destination? Earth. Will this space rock inflict unimaginable damage, or will it bring the spark of life?
This idea of a spark of life, we've all kind of seen it in the Frankenstein movies, right? It's alive. This comes from legend, from myth, from history, that there's some sort of a spark that differentiates cold, inanimate matter from living stuff. And in some sense, it's kind of true.
On Earth, we think this spark may have arrived over 4 billion years ago.
The Hadean Eon was the time from the Earth's formation about 4.6 billion years ago to about 4 billion years ago. It's named after literally Hades, so the conditions on Earth were literally hellish.
It was hot and soupy, a lot of water vapor around, high pressure atmosphere, very intense heat. You wouldn't survive. The planet would literally kill you back then.
It's shocking, and I mean really shocking, that the evidence of first life that we have on Earth dates to the Hadean Eon. This was a terrible place, molten and poisonous and awful, and yet life somehow arose in all of that mess.
June 2020. Japanese scientists simulate the conditions of this hellish planet and then try to recreate the spark of life.
So what the scientists were trying to do was mimic those conditions and see what would happen if you smash a meteorite into the ocean back then. Could it produce sort of the same chemicals that we see life using today?
They use a mix of carbon dioxide, nitrogen, water, and iron to replicate the Hadean environment. Firing a mini meteor at 2,000 miles an hour into this chemical soup triggers a reaction between the basic organic elements, creating amino acids.
We call amino acids the building blocks of life. Really, they're the building blocks of proteins, and life needs proteins to exist. But that's why they're so important. Without amino acids, there's no proteins. Without proteins, no life as we know it.
The experiment proves that meteorite impacts can help build the components for life. But for these building blocks to come together and create life, we need more.
It's like making a cake. You can put together the oil and the flour and the butter and the sugar, but if you don't put it in an oven, you're not going to end up with a cake. You're going to end up with something else.
We thought that the violence of asteroid impacts prevented life from forming. Now, we think they could be an essential ingredient.
If the asteroid impact is big enough and fast enough, it can punch right through the crust. Then you're getting geothermal heat, heat that bubbles up from the mantle. And it is certainly possible to get an asteroid impact that big.
Large meteorite impacts can create hydrothermal vents, which some scientists believe were the cradles of life. They provide warm, wet environments and bring up chemicals from deep inside the Earth's crust. The perfect place for life to begin.
As bad as those conditions seem to us, to the molecules that are beginning to combine and do their thing, that was a wonderful place to be.
It could actually be that the conditions that are best for early life might actually be those just after an impact. So you have sort of this petri dish environment in which life could really thrive.
These vents might be similar to those we see in the oceans today.
These hydrothermal vents provide a little window into what the conditions on the primordial Earth would have been like. And the sort of chemistry that goes on in those hydrothermal fluids seems to be the right kind of chemistry for creating life.
Once again, Earth got lucky. Impacts that could have destroyed everything may have helped spark life into existence.
I once heard this quote from Confucius, that creation is quiet, but destruction is loud. Well, these impacts were both destructive, but they also may have been creators.
Earth leaves behind the Hadean Age. The planet calms and life takes hold. But disaster is our constant companion as we prepare to face a storm of deadly cosmic bullets.